Hello, welcome to Rudy's Lab, and we're getting to one more episode about the use of the R&S CMU200 as a generic purpose instrument. And today we're going to talk about using it as an RF signal generator. And why is that an interesting topic? Well, there might be some point in your lab career where you're finding out that your regular trusted signal generator, like this Signalant over here, doesn't bring you anymore to the type of frequencies that you would like to be working on. When you're moving to the RF domain, you'll run into the limitation with these machines. No matter which version you buy, at some point they're going to end with 100, 200 megahertz or so, and you might be wanting something that really goes into several gigahertz, and then you're going to need a RF signal generator, a specific category of device. The problem here is these devices are expensive. They're very expensive if you buy them new on the market, but even if you buy a second-hand one, even the older ones tend to be quite expensive. You'll be easily spending €1,000 or more for a reasonable quality or in reasonable condition a RF signal generator. So now we're interested to learn whether our trusted CMU200 that might also fall into this price category and can do a lot of other stuff as well, actually might serve you as well as a nice signal generator. And the answer to that question is not so easy. It's a bit of a yes and no. In this video I'm going to show you that yes, it's a quite good signal generator, and at the same time it's a bit of a mixed bag what you exactly can do with it and what it is supported, and that has to do a little bit with the background of the device and how it was designed. So we're going to find some very unique features that you find on few other devices, but there are also a couple of other fields, etc., where you might be lacking particular things on this device. So that's going to be the focus of our video of today. Now, let me start with some things that I think are particular strengths of this machine. Later on we're going to go into some field experiment and look at all of them. And I think one particular strength is that this device can act not only as one, but also as 2 or 3 RF signal generators at the same time. This is going to depend on the options that you have installed in the device, but if you have option B95, then you can use up to 2 signals at the same time, and if you have option B96, you can generate up to 3 signals at the same time. Now, that is rather unusual for a RF signal generator. Why does the R&S have this? Well, this was designed as a mobile telecom tester. And there you often need the type of scenarios where a mobile phone is listening or communicating on several channels at the same time. So in GSM, for example, you could have one channel where you both have like the signaling information and the traffic information. So you would have what they call beach HHI and TCH in the same channel. But it's also very common in GSM base stations that you would have the signaling information on the one channel and actually the slots with the data with voice or traffic on another one, and that's what you want to be able to test with such a device as well. So that is really the reason why this device is often fitted with multiple generators. And in more advanced type of function, you can even use the third generator here, for example, as a 3G base station. So you would actually have a handover. You have a 2-channel GSM implementation, and that would have a non-blind handover basically to a 3G station. So all the signals are available at the same time. So it's really made for very advanced type of situations, very advanced modulator signals, all of these 3 modulators. What is left of that when you take it to generic use? Well, we can still use these 2 or 3 generators, but in a bit of a different sense. So let me point that out for you now. So for generic use, what we basically got here is the main oscillator, the main generator, can do amplitude modulation, can also do double sideband and single sideband type of modulation. It's quite generous. It can do tones up to 300 kilohertz of modulation there. Can do frequency modulation. Also quite generous with a 500 kilohertz frequency deviation. And optionally, you can also code stereo FM signals. So that is the main oscillator. The second oscillator, also called the auxiliary one in the CMU, and which is actually fitted into this device here, can also do the amplitude modulation type of thing, including the single sideband and the double sideband, but it cannot do FM modulation, and the same kinds of go for the third oscillator. I don't have that in my unit, so I can't test everything about that. There are a couple of things you should know about the second and the third oscillator, however. One of them is that they have rather limited power level. That depends a little bit on the precise configuration, and you can go back to one of my earlier episodes when I go in great detail about all the input and output powers of the device, where you can find it out. But generally we're talking about minus 60 dBm maximum or so. Also has to do with the reason why this device was designed in such a way. Also, in contrast to the main generator, the secondary, the second and the third one have a more limited frequency range. They don't do all the 3 gigahertz, although the bands that they do cover is still quite generous, I would say. And also the frequencies at which you can set them, it goes in 200 kilohertz steps, and I'll get back to that later as well. So we see 3 generators, but we also see they are quite specific in the way they can be used. Now, one more thing I should be saying about our 3 generators as well, which is certainly a big advantage of the CMU, I think, is that they can relate to the various in and outputs that we got here on the device. So what you can do is you can have these 2 or perhaps 3 generators basically, and have their signals combined into one single output here. So they're going to be superimposed on top of each other. But you can also decide to have the different outputs going to different output sockets here, output plugs. And that can be really handy if you want to do some design, for example, with mixers, and you want to again generate 2 different signals and want to look, for example, at the sum and the differences that come out of that mixer, etc. I mean, plenty of type of application that one can think of, but it's going to be very powerful basically that you have the choice also to have these signals coming out on separate outlets here. Now, one other field which is interesting to look at is the degree to what the device can actually use external signal sources for modulation, because you might not be satisfied with just having one sine tone or so that you could be modulating. And the CMU can do that, but it depends again a little bit on the options that you got fitted. Well, first of all, if you want to do regular type of audio frequency type of modulations, you can do that if you have the so-called amps option, which is a software option, and that would allow you basically to use the 2 inputs on the front to input an audio signal into the device. So that is one thing. When we really get to more complicated type of signals, actually we have another possibility, and that possibility is there when you have fitted the IQ IF card. And I've done that in this device. I made 2 episodes about how to do that. That was not so easy because of the lack of some information. But once you got that information, it's actually not going to be that difficult. And for that particular purpose, I also made this breakout box here. That provides me with additional IQ inputs and also outputs, etc. for the device. And then we get a whole field of new possibilities. So what we can do here is that we can actually input an external IF frequency on the device. That's going to be modulated around 13.85 kilohertz. That goes from the back of the device, or really enter I and Q signals directly into the device. That will set you back another, well, maybe 200, 250 euros for purchasing of the IQ card, but it really increases the possibilities with the generator a lot. Now, having talked over some of these particular strengths of the device, I will now go into some of more lab experiments, and there we're also going to encounter some more of its limitations. Okay, let's go and do some field experiments. We got the CMU here. Its second output is being connected to a spectrum analyzer, which is now running on its default setting, so stowing the total spam of 3 gigahertz in this case. And now let's focus on the CMU and get to the generic settings of the generator. So we'll be using base functions, RF functions, and there we already got our analyzer generator, which I'm selecting right now. And I'm coming here to the overall menu. We got the connect control menu, that's where we want to be, with the generator setting and the port settings. Now the port is already set here to output number 2, RF2, so that is fine. And we got the generator setting here with the first generator and the auxiliary generator. Now the first generator is set to 930 megahertz, and just let's turn it on. And yeah, we get to see our tone in our spectrum here. And I usually like to switch my spectrum analyzer to RMS mode. I'll do that right now, detector RMS. So what it's basically doing now, before it was in RMS mode, let me just go back to a regular mode. Before it was there, basically, every pixel or every vertical line you see here will basically show all the different data points that will be within the bin of that particular pixel here. So you see all the values that are present there. With RMS, it's going to take the root mean square of the value there. So that's usually my preferred mode, and then we get to see the tone much more clearly. Now we're not doing even any averaging. This is just the tone in RMS mode. Good. I'm also going to zoom in on the tone a little bit more, so I'll be basically putting a marker here. I'll set the marker to the peak, and I'll set the marker setting to the middle. So we got now our tone right here in the middle of the screen. And we can also kind of zoom in a little bit more on the tone here by reducing the span a little bit, because we see all the way still until 1.8 gigahertz. So I'm going to choose a span of, say, 600 kilohertz or so. I lost my tone, so I must have been slightly off in my search. So I'm going to go back to frequency, and I'll do 930 megahertz. Yeah, we got our tone back. And of course, we're getting a very coarse setting now, and that is because the resolution bandwidth is very big, 10 kilohertz. Let's put it at 1 hertz or so, and then let's not make it too slow. Move a little bit up in the picture. Yeah, so we get to see a nice tone. We didn't see any spurious elements or higher harmonics, so we really get a nice clean signal, and I do like that. Now, I was already talking about several options we got here, and one is basically the option to modulate the signal. So in modulation, we can do AM modulation. And let's just do AM modulation of 10 kilohertz or so, and then we very clearly see the two side lobes that we will be expecting in such an AM signal. Apart from AM, we also got single sideband. We would just get to see one lobe. We got dual sideband, so we get to see the two lobes, but not the carrier tone. And we also got FM as a standard. It gives a number of options here. If we choose FM, then depending on, FM is always available, but depending on the software options you have, you might also have FM stereo here. And then you also get the possibility to do all the settings relevant in the way that FM stereo is normally coded. So that's with a pilot tone that is just above the spectrum of the sensitivity of the human ear, and then we got the higher different signal between left and right. And interestingly, we can create a mono signal, a left signal, and a right signal. We cannot make a stereo signal. The sine tone that is put on the FM signal is just in the middle, on the left or on the right. So this is not meant to be a stereo amplifier, but this is useful if you want to test FM receivers. Okay, back now. I'm going to leave the device at AM settings with the two lobes here, and I want to take a look at this second generator that we have over here, because this is one of the nice pieces of functionality of the CMU. If fitted with the B95 or B96 options, you have a second or even a third generator here on the device. So I'm going to go there, and I'm going to turn that second modulator on. I didn't push the right button. I'm not seeing anything yet, but mind you, we have a fairly small span, and we might not be seeing the tone yet. We have to go all the way down to somewhere close to 930. Am I getting close? Yeah, I see now something coming here. Now it disappeared, and now it's over there. So what we're actually seeing here, well, there's a couple of things. First of all, this is a fairly weak tone. The maximum power in this particular setting of the device is minus 68 dBm. It's a much weaker tone than the main tone. It depends a little bit on which option you have installed, but generally the second generator is making a much weaker tone. Let me just turn down the main device a little bit so so tones get a little bit comparable here. There we go. The second thing we note is that it is also modulated in the same way as the original modulator, so we have an AM tone in this case as well. It also does so for sideband and for single sideband, dual sideband. It doesn't do so for stereo. If you put on stereo, he will just turn the second generator off because that is not supported. We'll have only the first generator on. But the other thing that we note is that I only could put it here, here, and here. So what is going on here? 930.2, 930, right over the other one, 929.8. There's nothing in between. Even if I would try to do that with settings over here, I cannot go there. Even if I try manually to enter 930.1, no, it's going to 930.2. What is going on here? Now here again, I'm pretty sure we need to be reminded of the original roots of this instrument, a GSM protocol tester. And in GSM, basically, the spacing between GSM channels is 200 kilohertz. And this second generator was really designed to be there to kind of create second or third channel for GSM signals. So you could have your data on one channel and the signaling, BCCH, as it was called in GSM, on the other one. And I think that's the exact reason why we see these broad steps here. Is that limiting us in any way? And let me just see, I just brought it out of the picture. Here we got it back. Is that limiting us in any way? Well, not really, because the main generator can be put in any frequency that you will be interested in. So if I go to my main generator here, and let me just put the cursor where I want it to be, you see I can move to any spot here. Now, I can also choose basically to have these signals not being combined, superimposed on the same output, but basically go to another output. If I would go here, I would take here the external out and I will basically put it at the other channel. Well, I see it disappearing here, but now it comes out. Now it comes out over here. I see the other light here going on. It has not disappeared, but now it's actually coming out of the other output. If I would connect my spectrum analyzer here, we would have it over here. This can be very useful if I would like to, for example, do some testing with a mixer and create two different signals and then try to measure its sum and difference and that type of things, etc. That's a very interesting thing that we will be able to do with this instrument. Now I'm getting back the second tone right where it is. So altogether we see this is behaving exactly as expected. We see very little spurious tones and everything. I think the R&S Schwartz, even if limited in some ways, is quite well behaved when used as a signal generator for generic use. Now, one of the things that the CMU does not have, and what you would find in many even basic RF signal generator, at least analog one, is a sweep mode, going from the one frequency to the other frequency. We do have another functionality that kind of has some overlap with it, and I'll like to take a look at it now. And you get there actually by pressing the second time on the generator button. You see here this little yellow triangle. So if we just press it once, we go to the generic settings. If there's a triangle, we can press it twice and we get to a more detailed screen. Actually, there is a lot of detailed parameters that we can actually get into here. So what I'm going to do right now is actually I'm going to turn all of them off that I don't want to look at, and I'm going to go here to the so-called list mode. And the list mode is actually a software option, so you must have it activated, and it's available in the more recent firmware versions. So if I go to the list mode, basically I will be able to create a list of frequency and level events on the device, and by default you see here they're all programmed to the same frequency, but I can change that, and I can select how long that list is over here. So I can go here and I think it go all the way up to 500, 500 events. I will give a little demonstration now, and I'll try to do, say, 20 events here, and I would need to type the frequency for all these individual events. Now typing them all here on the keyboard might take a little bit of time, so what I did basically is I took an external keyboard. This is the more recent version of the CMU, so I got a USB connector. In my older CMUs I have there's the PS2 connector, but with a little adapter that works perfectly fine. But anyway, I can just go to my keyboard here and like type in all the different fields the frequency that I want, like 810, enter, and key down, and 815, enter, and key down. So using the USB keyboard really makes that process much faster. I'll just put the video in fast forward, and I'll be typing all the frequencies that I want to enter now. Okay, I finished filling out all the frequencies, so I'm making 5 megahertz steps all the time, and also for each of the individual steps I can set a particular power level. I'm just going to leave it now as it is. I'm going to go back to my overall settings here, and I can basically set also the time that it takes between steps. So now it's at 0.5 milliseconds. That is very short. We won't see that so fast with the human eye. So we're actually going to set it on a higher value. I'm just going to try to see what the highest value is allowed, and it's going to tell me that 100 milliseconds is the highest value. That is fine. 100 milliseconds, I should be able to see it. Now let's go and quickly take a look if this works. I go here, I choose run. Yeah, and exactly as expected here, I nicely see the frequency going up in 5 megahertz step. So this can be a quite useful functionality for a number of different use cases, I think, where you want the spectrum analyzer to go to different frequency points and perhaps different power levels. And it can be in many cases, I think, an alternative for sweeping, but perhaps not for every case. May also generate some new use cases. Another feature, and I don't want to dwell on it too long, but I quickly would like to share it with you here, and I think we will find it here if we go to the main generator setting, is frequency hopping. So we can also have the device hop fairly fast from one frequency to the other frequency, and we can also decide on some ramping parameter there. So this can be a very useful RF setup as well, and this type of hopping of course is also used in GSM, and there it's important that you actually have a signal generator that can jump very fast from one to the other frequency and still remain totally stable in the work that it is doing, and I think the CMU is relatively good at that job. Now one thing that a powerful signal generator will be able to do is basically modulate your own incoming signals, and preferable also wideband and even complex vector type of signals. Now the nice thing is that the CMU basically can do that, at least if you have the B17 IQ card fitted in it. And I fitted it into this unit a while ago. I also made two video episodes on that. And as part of that exercise, I made a breakout box, which you see over here, which basically offers me the 2 additional I and Q inputs. So now I'm going to try to actually input an own complex signal into the unit. And where does that signal come from? I'm taking it for a unit that is just below, and I'll move my camera a little bit so you can see it. It comes here from my new Anritsu vector signal generator, a very interesting device. You'll soon be hearing more about it in later episodes. but let's not talk too much about it right now. But anyway, what is the Anritsu creating for us? It's creating a digital video signal. It's a DVB-C, DVB cable signal, so that's a European standard, and that is a digital video standard, yeah, as the name says, to be used in cable networks. It's a complex 64 QAM signal, so it's also relatively broad in bandwidth. And now we're going to try to see if we can use the CMU to modulate that signal on a high frequency carrier. So right now I got kind of a standard tone being generated, a AM modulated tone as we've seen before. The tone is at 810 kilohertz here, and I'm basically going to tell my CMU now basically to take the external input instead of my AM modulation. So I do that by going in the setup or the connection menu to the IQ option, and for the transmit path I will basically here go and choose IQ in and out, and I'm going to select that. I'm going to take a look at my spectrum analyzer, and the signal disappears. Well, it doesn't really disappear. If you look well, actually it got a little bit higher. So what we're seeing here, actually this is our wanted signal, but the bandwidth is much wider than the signal I was just previously looking at. So we'll need to increase the span of the spectrum analyzer. I know that digital video signal is going to be like several megahertz broad, so I think we can easily go to 30 megahertz of span here. And it's going to be a little bit slow, so I'm going to increase basically the... Yeah, I already see it coming. Yeah, this is exactly what we expected. A nice broadband type of signal, modulated complex signal, modulated by the CMU. These digital video signals were supposed to be part of a 8 megahertz raster in a television system, so it's going to be slightly under 8 megahertz of bandwidth here. We can quickly check that with our markers. Let's put one marker on the beginning of the signal. And let's put the second marker. It's going to be a delta marker here on the second part of the signal. 5.6 megahertz signal that I'm modulating right now. So we can deal with relatively broad signals here. And one of the things that also might want to try here is actually use my second generator now in the CMU. So I made my signal a little bit weaker. My wanted signal, brought it back to minus 44 dBm or so. So I'm actually going to activate now the second generator. Yeah, and there we got it. We see a tone coming in. It's an unmodulated tone right now, coming in at 818 megahertz, and I can move that tone basically around. Goes a little bit up and down, but that will be the result of the resolution bandwidth that I've selected. But I can even bring that tone over my wanted signal, and I could investigate, for example, how a given receiver would react to the presence of a strong tone close to the carrier, or even going within the frequency of the carrier. So it might, it might somehow mutilate the signal. If we talk about the ODFM signal, it might actually take out some of the particular carriers that are in there. So for this type of experiments, etc., I think it's very useful basically that we have this second generator in the CMU and are able to use the combining function, bringing that all into one single output of the device. So wrapping this all up, is the CMU a interesting RF signal generator? Well, as with every device, I would say it has some advantages and disadvantages. One clear advantage is having these 3 different channels. Depends, however, on the hardware version of the device that you have. One clear strength is that you can modulate external signals into IQ, including IQ signals of quite significant type of bandwidth, etc. We see a couple of advanced functionalities that include like frequency hopping and this list mode where we can program 500 different frequency and power points that we can have the device running. And that it also has all these advanced signals basically for telecommunication standards, which is not the focus of this video, so I've been staying away a little bit from it, but especially when we go there, and I'll plan to do that in a later episode. We've got plenty of other possibilities. So the device comes also with a number of downsides. There is not, for example, something like a sweep mode, something that you would find on most of these RF signal generators. There are no built-in generic type of IQ or vector signals that you could be using. There's nothing like arbitrary waveforming playback or the option to fit memory to do such a thing. And these second and third generator that I already talked about are somehow limited in terms of the maximum signal power they can deliver, the frequency bands in which they can operate, and into a couple of other dimensions. Having that all said, is it worth basically to get a CMU as a signal generator? Yeah, I kind of think so. Given that RF signal generators are very expensive devices, new but also second-hand, generic type of devices like normal signal generators really can't get you into the RF domain. And if a CMU basically also offers all the type of functionalities that you'd be interested in, then actually it could make a very good deal basically to provide you also with an RF signal generator. And actually I've been using it already for quite a couple of my own experiments in my lab. Okay, that's it for today's video. I hope it was useful. Do subscribe to the channel and like the video. There's going to be upcoming new episodes. It's going to be a little bit more on the CMU, I think, but there's definitely a couple of new devices that are going to turn my attention to in the videos that are going to come out in the near future. Thanks for watching.